21, a random sample of size n is drawn. The sample mean x bar is found 17.8. Sample standard deviation S is found to be 4.4. Icon view the t-table. We're going to construct a 95% confidence interval about the mean if the sample size is n equals 34. So since the sample size is big enough, we can use the normal approximation. The mean 17.8. Standard deviation S, which is going to be divided by the square root of n. So we're going to do 4.4 divided by SQRT square root of 34. So this will give me my mean and standard deviation. And oh my gosh, we're doing the confidence interval, sorry. C-stat. Sample mean 17.8. Standard deviation 4.4. Sample size 34. So do a confidence interval 95. Alright, so confidence interval lower limit 16, 32, and then 1928, 16, 32, 1928. Construct the 95 about the mean if the sample size is 61. Okay, so same thing. We'll go here, square root 61. Oh, sorry, wrong thing. Edit this. We're going to do sample size 61. And then a 95% confidence interval there. Let me close this out because that's throwing me off. I'm trying to use normal distribution. So confidence interval here will give me 16.7. And this one is 18.9. Alright, so it says, how does increasing the sample size affect the margin of error? So if we look at this interval 16.3 to 19, the width between those two, let's just say 3. It's about 3. The width between these is about 2. So increasing the sample size decreases the error. If I get more data points, I'm getting a better estimate. So I'm having less error. So the margin of error decreases, which you can see. I'm going to construct a 99% confidence interval if n is 34. I'm going to just do this, edit, and we're going to do 34. We're going to do level of confidence is 99. And we get 15.86 to 19.74. I'm going to compare the results to those obtained in Part A. How does increasing the level of confidence affect the size of the margin of error? So bigger, the more confident, the wider the interval is. So same sample size, 34 and 34. but this interval goes a little bit bigger to make sure we're almost like overcorrecting. So more confidence equals a bigger margin of error. And then if the sample size is 16, what conditions must be satisfied to compute a confidence interval? So using the sample mean, it must be either normally distributed or we have a sample size that's big enough. Should not have any outliers. Sample size must come from population that's normally distributed. Sample size must be large enough. So we're going to say sample size must be large enough, no outliers. Outliers will throw off our data. So sample data must come from a population that is normally distributed, no outliers. Sample size must be large enough. Are there more options? And they should have no outliers. The sample size must come from population normally distributed, and the sample size must be large enough. So you need one of these. You don't have to have both, so we're going to go with B. And 21, this one wants us to put these in order from widest narrow to wide, so the smallest to widest. So the lower your level of confidence, the more narrow. So B would be first, and then the more confident you are, the bigger you're allowing yourself more error. So B and then D. So looking at A, B, and then D, so A is going to be the only one. All right, we're going to submit.